Hello everyone. Today we will see about the introduction of inorganic polymers. So these inorganic polymers they are also polymers which do not contain a carbon atoms in their backbone, right? So inorganic polymers, they are linked together by covalent bond. The polymers containing the organic and inorganic constitute are called hybrid polymers. In most called inorganic polymers are almost all inorganic polymers are hybrid polymers. That means, right? Some example of inorganic polymers are like polyphosphate, polyphosphagene, silicon, and polyrazine. Similarities between the organic and inorganic polymers. Similarities between the organic and inorganic polymers, they are: one similarity is in both the organic and inorganic polymers are linked together by covalent bond. That is one similarity we see in the inorganic and organic polymers. The both are macromolecules with high molecular masses. So both the organic and inorganic polymers, if you see, their bond are linked by the covalent bond, and they are both macromolecules and molecular with a high molecular mass. Because of their the polymers are formed by the large number of monomeric units linked together, right? So the main difference we see in the inorganic and inorganic polymers are: in an organic polymers, we see the carbon atoms in their backbone, whereas inorganic do not contain any carbon in their backbones, right? This is the main difference. In organic polymers, you see carbon atoms present, whereas inorganic polymers do not see any carbon atoms. The organic polymers are simple structure, while inorganic polymers are highly branched with a complex structure. Most of the organic polymers are eco-friendly because of their biodegradable, whereas inorganic polymers are non-eco-friendly because they are not biodegradable. So these are the three important points of organic and inorganic polymers differences. Okay. So now, as I've told, in the inorganic polymers, you don't see any carbon atoms. Their bonds are linked by covalent bond, right? So the macro-sized covalent molecules which do not contain any carbon as backbone, they are inorganic polymers, right? So they are classified into four categories: on the basis of atoms in their skeleton, on the basis of elements present, on the basis of method of preparation, on the basis of conjugated atoms present. So these are the four main classification of inorganic polymers. Let us see one by one. So on the basis of atoms in the skeleton, they are divided into two types. One is called homoatomic polymers. In this type of polymers, you will see only one types of elements are present. Example like silicon, phosphorus, tin, sulfur, germanium. Whereas in the heteroatomic polymers, you see two or more types of elements are present. Examples like silicon. In silicon, if you see the silicon, you will see a organosilico compound, right? Something like this you will see, right? So on the basis of atoms in skeleton, they are classified into homoatomic and heteroatomic polymers. On the basis of elements present in the skeleton, they are divided into four. Some example like boron containing elements of polymers like polyrazine, silicon containing like a silicon, phosphorus containing are metaphosphate, polyphosphate, phosphonitrile halide. So, and the sulfur containing polymers like nitrates of sulfur, sulfur of thioacyl halide, amide of sulfur. So these are some examples of on the basis of elements present in the skeleton, they are classified in the following types of examples. On the basis of preparations, they are divided into three types, like condensation polymers, adhesion polymers, and coordination polymers. Condensation polymers, right, when two or more similar types of simple molecules polymerize to get the condensation polymers. Example, in this type, elimination of water or ammonia or hydrogen or HCl molecules takes place in the condensation polymers preparation, right? In addition of monomeric unit, you see when sulfur trioxide is present of water give addition polymer, right? So these are some types, and the coordination polymers also coordinate bond between the metals and the ligands. Chelate containing metals that can form such type of polymers. It can also prepare through elimination or addition reaction. So on the basis of on the basis of method of preparation, they are divided into condensation polymers, addition polymers, and coordination polymers. So condensation polymers, some examples like this: when SiC this is R2SiCl2, right? When can react with the H molecules, you get it polymerize into silicons, right? This is how later on we will see during the preparation of silicon. As I've told, silicon is prepared by this organosilicon method, right? So condensation polymers, where the eliminations of water takes place from here, right? So the four types is conjugated atoms presence. On the basis of conjugated atoms presence, silicon inorganic polymers are further divided into conjugated silicon, right? Silicon and related compounds polymer containing polymers. Conjugated phosphorus, where the nitrogen is present, phosphonitrile halide. Conjugated sulfur, here also nitrogen is present, beta phosphate, polyphosphate, cross-linked phosphate. So these are some types how the polymers, inorganic polymers, are classified. So these four are the main important types how the inorganic polymers are classified in the inorganic chemistry. So we will see one by one a few types of inorganic polymers in the upcoming video. For this video, we'll stop from here. Thank you everyone for watching the video.